Okay, so topic 9 is going to focus on the least common denominator, which is a huge step to getting to the point where we can add or subtract fractions that have different denominators. And I do want to add a quick note here. To add or subtract fractions, you must have a common denominator. And so that's going to kind of be the focus of this video. We want to know how can we find that number that is going to be the common denominator, okay? So let's talk about some definitions. First, the least common denominator, we typically call it the LCD. So if I say LCD, you need to just think least common denominator. So the LCD of a list of fractions is the smallest number divisible by all denominators in the list, okay? So I'm going to write another little note here. It is the smallest multiple, and we'll talk about multiples in a second. It is the smallest multiple common to all of the denominators. Now, in case you're a little bit unfamiliar with multiples, you're going to take a number and multiply it by some other number. So if I had, in the example that we list here, the multiple of a number is that number multiplied by any non-zero whole number. So we're going to talk about 9. 9 times 1 is 9, but 9 times 2 is 18. 18 is a multiple of 9. 9 times 3 is 27. 27 is another multiple of 9. There are infinitely multiples of a number. Okay, there are infinitely many multiples of a number. Okay, so what we're doing is we're going to look at how to find a least common denominator. And there are basically two methods. One involves multiples, the other involves prime factorizations. Okay, so let's see what we have here. So the two methods for finding the LCD, method 1 is the one that students tend to like, but it can get a little out of hand sometimes. So with the multiples method, you list out the multiples of all of your denominators. You generally start with the larger denominator, list out several multiples starting with the denominator itself. Then you go to the other denominators, list out multiples of those. And as soon as you have a multiple that's common to all of your denominators, that becomes the LCD. So it's a very easy method, but it can really get drawn out depending on what the LCD is. The second method is the one I tend to like. It uses prime factorizations. It takes a little bit to learn the method, but once you have the method learned, it's really nice, especially when you get kind of a wacky LCD and you get kind of lost trying to list out all these multiples. The prime factorization method can get you there quicker. Okay. So what we're going to do is we're going to look at an example of both. So we're going to find two LCDs, one using the multiples, the second using prime factorizations. I'll kind of explain that method more when we do it, but you ultimately find prime factorizations of all of your denominators, and then you look for groups of factors, but I use a table that I think makes it a little easier to understand. So let's look at example 14. It says find the LCD for each group of fractions. For the first example, for part A, we're going to look at finding multiples. So I'm going to start with 20, and I'm just going to list out several multiples of 20. So you start with the number itself. So 20 times 1 is 20. 20 times 2 is 40. 20 times 3 is 60. 20 times 4 is 80. 20 times 5 is 100. We can come back and list out more if we need to, okay? Now we need to list out multiples of 12, starting with 12 itself. So 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. 12 times 5 is 60. So there we have it. We have the smallest, my hair got in my face. We have the smallest multiple common to both of these denominators. So we would say that the LCD is 60. So if we were adding two fractions or subtracting two fractions that had 20 and 12 as their denominator, the smallest multiple that they have in common, the smallest common denominator that we could use would be 60. Okay. Now for this next example, we're going to do the prime factorization method. Okay. So for the prime factorization method, it takes a little bit of time, but it's really good to use if you kind of get stuck and you can't find your LCD. This is kind of, even though it's a little bit more involved, this is kind of the go-to method, okay? So what you do is you start with each denominator and you find the prime factorization. So we talked about prime factorizations way earlier in this worksheet. So you may have to go back to that and review a little bit. But basically, you're going to do what's called a factor tree. We want to look for factors of 24. Any two factors of 24 will work. I want to use 4 and 6. Neither of these factors is prime, so we want to make two new factors. So 4 I could write as 2 times 2. 6 I could write as 2 times 3. So my factorization, my prime factorization of 24 is 2 times 2 times 2 times 3. We're going to repeat this for 20. So you could use any two factors that give you 20. So you could use 2 times 10 or 4 times 5. I like 4 times 5. So 4 is not prime. So I would write 4 as 2 times 2. 5 is prime, so I just bring it down. And then we're going to look at 60. You could use any factors of 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12. I just happen to like 6 and 10. So I'm going to use 6 and 10. Now, if you used other factors, your factor tree would look different than mine, but the final line would be the same. So the prime factorization would be the same regardless of which factors you choose. The body of the tree would look a little different though. All right, 6 is not prime, so I'm going to write that as 2 times 3. 10 is not prime. I'm going to write that as 2 times 5. Okay? And then I like these to be in order, so I'm going to come down and just rewrite the prime factorization of 60 as 2 times 2 times 3 times 5. Okay? So now we create a table. My neighbor drives a dump truck. That's what you're hearing all day long. All right. So what we do now is we create a table. So we want to have a row for this table that consists of each denominator. So I'm going to have a 24 row, a 20 row, a 60 row. And then I'm also going to have an LCD row, but I like to separate it out. Okay. Now, what you want to do is you want to list out one of the factorizations to start. Doesn't matter which. Let's say we start with 24. So 24 is 2 times 2 times 2 times 3. What those factors have created are columns. Once a number is in a column, that is the only number that can go in that column. All right. So I've got my factorization. Those lines are slanted. I've got my factorization for 24 done. Now I want to fill in the factors for 20 and 60, and I want to overlap as much as I can. So I want to fill these columns up as much as I possibly can. Okay. So for 20, I have a 2. I have another 2, but then I have a 5. There's not a column that has a 5 in it, so I have to start a new column here. So I'm going to start a 5s column. Okay. Now I want to fill in the factors for 60. And again, I want to put as much in the columns that are already there as possible. Only start a new column when there's absolutely no column left. Okay. So for 60, I have a 2. I have another 2. I have a 3, and I have a 5. So what we're doing is we're taking out the overlap of factors that show up more than once. Okay. So then what you do is you bring down the representative from each column. So the first column, excuse me, the first column was a 2. The second column was a 2. The third column was a 2. The fourth column was a 3. And the fifth column was a 5. This product right here becomes your LCD. So 2 times 2 times 2 times 3 times 5. So let's see. 2 times 2 times 2 is 8. 3 times 5 is 15. So let's see, what is 15 times 8? We can do a little side work. If you already know it in your head, like a lot of us do, it's fine. But let's do side work in case you're stuck, or you can cheat and pull out a calculator. 5 times 8 is 40, so I keep a 0. I carry a 4. 8 times 1 is 8, plus 4 is 12. So the LCD here is 120. Now, without a shadow of a doubt, the prime factorization method does take more work. But sometimes the multiples method, you'll list out multiples and multiples and multiples and multiples, and you just can't get to that LCD. So sometimes the prime factorization method is going to be better, but do whichever one you prefer. All right. So the next example says, fill in the blank to create equivalent fractions. So you do need to recall, remember, equivalent fractions from earlier in this worksheet. Equivalent fractions have the same value. All right, so there are two fractions that look different, but they represent the same amount, okay? So we did a couple of things with equivalent fractions. We learned how to check to see if two fractions were equivalent. That's where we compared cross products. We also created equivalent forms of fractions by just multiplying the numerator and denominator by the same whole number. We also learned how to take a fraction and reduce it to an equivalent form. So we've done a good bit with equivalent fractions. So let's practice again. So the directions here, again, they say fill in the blank to create equivalent fractions. So this may feel like a really hard puzzle, but just think about it. We know that for part A, we're starting with 7/8. We somehow need to convert that to something out of 56. So ask yourself, what do I multiply 8 by to get 56? You could also say, what is 56 divided by 8? Okay, either one of those will help you out here. So if I look at 8, I'm like, what in the world would I multiply 8 by to get 56? 8 times 7 is 56. If you can't figure out what to multiply 8 by to get 56, do the reverse. If I take 56 and I divide it by 8, what do I get? Well, 56 divided by 8 is 7. So essentially what we do is we multiply the numerator and the denominator by 7, and that'll give us an equivalent form of this fraction with this new denominator 56. So 7 times 7 is 49. Now remember, if you want to check this, you can. We do that cross multiply thing. So we would ask ourselves, is 7 times 56 the same as 8 times 49? Well, let's go to a calculator and see really quick. I don't feel like doing the side work for this one. All right, so the calculator we want to know is 7 times 56 equal to 8 times 49. Well, in both cases, we get a product of 392, so that tells me that the cross products do match. So we can go back here and say confidently that 7 times 56 is 392, which equals 8 times 49, which is 392, so we are good to go. Okay, now let's mimic that for part B. We have 3/5. We want to rewrite it as a fraction with 100 as the denominator. So the question you could ask yourself is, what do I multiply 5 by to get 100? Or what is 100 divided by 5? So 100 divided by 5 happens to be 20. So that tells me I need to multiply the numerator and denominator by 20. And that gives me 60 over 100. And if you want to check it, you certainly can. We would say, is 3 times 100 equal to 5 times 60? Well, 3 times 100 is easy. That's just 300. 5 times 60 might be a little harder, but just take 5 times 6, which is 30, and then add another 0 to it, and you do get 300. So we are good here. So the blank that we would need to fill in would be 60 for part B. All right? So make sure you know how to find an LCD. Either method is fine. And then just don't forget this whole idea of equivalent fractions, because that's going to be a big part of the last topic.